Okay, hello everyone. Kumusta? So I'm here to discuss a moment of a force. Okay, let us define the term. So this is a measure of the tendency to produce rotation of the body upon which the force is acting about a specific point or axis. It is also a vector quantity, thus it contains magnitude and direction. Okay, here's a figure. This is the force applied, and this is our moment center. And I have a line passing through the moment center. The line is actually parallel to the line of action of the force. Now, what is the moment of the force about a point A? Okay? So, the moment of a force about A is a product of F times D. This one. We have F times D. So, what is F? That is the applied force. And your D is the moment arm, a distance or a perpendicular distance between the line of action of the force, and the axis of rotation. This one. So, sa line of action mo diha, then take a perpendicular distance D. If you multiply this D with the applied force F, then that is the moment of the force. Now, since this is a vector quantity, so we have to take a sign conventions for the magnitude of your moment and in relation to its direction. Okay? So, these are the sign convention. If the rotation is clockwise, you may take it as plus. The opposing sense or direction is taken as negative. Or you can also start with a counterclockwise sense being positive. Then, so what is important there is you have two opposing sense of different signs. Okay? So, couple. Okay, what's a couple? Dili ng couple na sa toa. Okay, wala. Couple, it consists of two parallel forces equal in magnitude but opposite in directions. They are separated by a distance d, and that is known as the couple arm or the arm of the couple. Okay, so if this is the figure, there is a body acted between two parallel or acted by two parallel forces of equal magnitude F. Okay, separated with a couple arm or an arm of a couple which is D. What is the couple moment or the moment of the couple? No? Mahimo kang couple sa imong moment. Bitaw kini. What is the moment produced by the couple? It's a product of a force F times the distance or a couple arm D. Okay, so that's the moment of the couple. Now, we have characteristics of the couple. If we take summation of forces vertical, because these forces are acting vertically, so we call that as the resultant of which must be made zero. Because they have opposing sense, the magnitude are the same, so their summation must be equal to zero. Then the moment of the couple, as defined green, is a product of F times D. The moment of the couple is this if the couple is the same in all points in the plane. Okay? So, we have the principle of moments or commonly termed as the Varignon's theorem. The moment produced about a point by a resultant of a components of forces, no? The moment of which is equal to the sum of moments of the components of the force. Okay, about the same axis of rotation. Okay, panalitan, this is the figure. If I take moment about A, your arm has a distance of D to A, then it can produce a moment. The moment produced, if this is the resultant of if1 and if2, then the moment produced by your R, which is R times T, is equal to the sum of moments produced by if1 and the if2. Okay? What is the moment produced by if1 to A? That is if1 times D1, if2 times the D2. So, R times the D. So, you can form the equation out from the Varignon's theorem. R times D, that's the moment produced by the resultant, and this is the sum of the moments produced by the components of your R. According to the Varignon's theorem, the sum of this moment is equal to the moment produced by the resultant. Now, if you are asked to determine the moment at a given point or moment center A and C for the figure given. This is the location of A. Okay, where is A? This one. This can be used as the moment center as indicated here. Another moment center is C. Okay, so I can work first with A. Now, for the distance of your 80 pounds, this one, Actually, you don't need to reduce this in terms of component if by extending this, following the line of action of the force, you know the perpendicular distance of the line of action of the force to A. But since that is not obviously shown, no? Then I can maybe reduce this in terms of component. Okay, so this is where the components of the force may be useful in this kind of problem. Because if this is reduced in terms of a vertical component, I can easily determine this as the moment arm, or I can make use of this being the moment arm of the vertical component of 80 pounds. The horizontal component of 80 pounds, no? So it's actually a force whose line of action passes through the same point A. So that means the distance here to A will be 0. Or that means the horizontal component of this load is 0 because it will not produce a moment when the line of action of the force will pass through the moment center because your D will be equal to 0. Now, just like this, no? If this is extended, I cannot determine right away the distance, the perpendicular distance to A of its line of action. Because if that is possible to identify, then I don't need to reduce this in terms of component. Okay? So, since that is not the case, so I have to go with the reduction of this in terms of component. Okay? So, I have to show you how to reduce again, or let us review on how to give the components of the force. Okay? So, previously, we were done in the discussion of the components of the force. So, this is just a review. No? Okay, this one. I'm reducing in terms of vertical and horizontal component of 80 pounds. Okay, so my vertical component is here acting. Okay, or it can be here, pero naman ay imuhang point of application. So, I put my vertical component right here. This vertical component in relation to the angle given is adjacent to 28. So, if that's adjacent, then it is related to a cosine function. No? So, if this is your 80 pounds, so just multiply 80 with the cosine of 28. This one, okay, even though this is not really necessary, why? It will pass through A and it cannot produce any moment. No? But this one, ako lang gibutang just for purposes of recalling. Now, this component is actually the same component which can be found here. No? So, that component is opposite to 28. So, I can make use of sine function. So, 80 times sine of 28. Okay? This force, no, the angle of inclination is not given, but you are given a slope. 4:1. Correct? Okay. So, if I'm going to reduce this in terms of a vertical component, the arrow here is downward. So, the component is also downward. So, it would be 50 times. Okay, it should be 4. What is the hypotenuse when you have 4 and 1 being the sides of your right triangle? So, it can be square root of 4 squared plus 1 squared. That is 17. Square root of 17, right? Okay. So, just multiply 50 with the vertical side over the hypotenuse of this. So, 4 over square root of 15. In similar manner, if I have to go with the horizontal, this horizontal is parallel to 1. So, it should be 1 over square root of 17. Ganina, the vertical is parallel to 4. That is why I have 4 square root over square root of 17. So, it's 50 times 1 over square root of 17. Okay? Let us proceed with the computation of moment at A. The moment at A, so 80, where is 80? 80, this one. Now, I take moment, no, there is a negative sign. The rotation with respect to A of the force, no, when applied into the body, can produce a counterclockwise rotation. So, my assumption there, or my sign convention adopted is counterclockwise is negative. Or counterclockwise moment is negative. 80 cosine of 20. This force has a distance of pila? 2 and 3.5, so 5.5 in feet. No? So, pound and foot. Okay, unit. So, another force. No? Kine, forget about this. Why? This will not produce a moment because the moment arm of this is 0. Any force which will pass through a moment center will not actually produce any rotation of the body. Okay? I may proceed with these two forces. I can maybe start with this. Okay? If the push is applied here, and my point or my moment center is here, so the body or the force will actually produce a rotation which is, sa imong rotation? Okay, so that is still counterclockwise, di ba? Counterclockwise, no? So that means this is 50. Then the distance padong sa A is still 1.8 kini. So it is 50 times to reduce in terms of component multiplied with this distance. That is maintain 1.8 dire. Okay? So 1.8. Another force is asaman. Kini unsa man ni siya? This is actually a couple. Your couple is also counterclockwise. That's why couple is considered 40, but this is already a unit of pound foot or foot pound, no? So that means you don't need to multiply anymore with any distance because this is a couple, so no need to multiply a distance. No? So kana, we reduce that in terms of moment, and this is the moment of your couple also. So just take the value, negative, because it's counterclockwise, correct? Then this one. Last is the one. So first, I collected all negatives. Na? Then, I take the force that produces a clockwise direction, rotation, kini, clockwise man with respect to your A. Now, if the body is poser, so that will pose the body and produce rotation which is clockwise. So, 50 times to reduce to vertical component, then this distance. Pila ni? That is 8.5. Okay? By calculating, you arrive with a result. So there's a negative 38.015 pound foot. Then, it is negative. It means the rotation produced by these forces is unsa man, counterclockwise with respect to A. Okay? Now, how about the moment produced at C? Okay? The moment produced at C. This one. The moment produced at C, if I have this one, ang 60 ganina is not included in A because 60 passes through A or located exactly at A. So do not include that one. Any force which will pass through a point or line of action moagi on the same point, then do not include that in the moment summation. Okay? Now this time I have C. So what is not to be included is this one. No, because this is located at ET. Even if this is not located at ET, but its line of action will pass, even though it is not located at C, but its line of action will pass through C, then you should not also include that moment, the moment produced by that force, because the moment of which is, again, B0. Now, if I have to take a moment at C, 60 can produce a rotation which is ipos. So that can produce a rotation which is clockwise. So 60 times a distance of 5.5. And I have this one asa pa. Okay, so gini. 50 times 1 square root of 17 with respect to say that is clockwise. Distance is 1.8. No, maoro man na. The line of action is here, so that's 1.8. Perpendicular distance must be considered. Minus the. Okay, so we also have kini, which is this one. This is counter. So if that's counter, it is minus. And I have kini 50 square times 4 square root of 7 over square root of 17. This will produce a rotation which is clockwise. Distance is 3. Okay, by taking the summation, we arrive a value which is 413.693 pound foot. Positive means a clockwise rotation to C. If all the forces, the moments of the forces considered, the net effect of which is if to produce a rotation which is clockwise. Okay, so that is the moment of the force. Okay, I hope you were able to follow. So thank you for watching, and let us proceed with another topic on next video. Okay, so bye-bye.